shot at this every day. Okay, so it is that what is a function? The x values or the domain cannot repeat for a relation to be a function. We did this in 8th grade, and so if I look at these order pairs, it says which one is a function. And I always taught in my class that you circle the x's because then it makes them stand out. And is that a function? No, because your 2's repeat. So then I've got 0, 3, 0, oh, 0, 1, nope. And I've got 2, -1, 4, and 6. Looks like a function to me, doesn't it? I'm going to double check. I got -1s here, so not a function, so my answer would be C. Okay. What's the difference between a relation and a function? Okay. A relation and a function is a relation. Sorry, I will try and get used to holding it up higher, okay, because with more of you in here. My problem is I'm trying to manage this darn camera, and that one day I'm going to get one of those that does both at the same time. Okay, a relation. Any set of ordered pairs. It means you could have those ordered pairs in a table, in a graph, in a just as ordered pairs like we had up here. It could be in a word problem where more than one thing is related. Okay, a function occurs when a relation includes only, oh, that's bad. That's really bad wording. When a relation includes only relationships, that's relationships where each x value, you can always use up here, x value has one and only one y value. X's can't repeat, which we wrote up there. Okay, so by that meaning each x can only be paired with one y. Now more than one x can be paired to the same y. Okay, so your y's can be repeated but not your x's. How do you determine if a relation is a function from a table or a graph? Pretty much we're saying the same thing, kind of, but table. Each x value will have an unique y value. That is a function. In a graph, do you remember what we used for a graph to figure out whether it was a function or not in 8th grade? Use vertical line test is what we call it. Okay. When you draw vertical lines, your drawn line cannot touch more than one point. I know, I'm getting it in there at a time. So, what do I mean by that? I'll come up there in a second. And it could be you can't touch more than one spot on any given line that's drawn on your graph either. Do you remember what I'm talking about, or do I need to give you a demonstration?
I remember.
Who doesn't? Okay, so everybody's going to tell me that they did. So when you go to do your work and you have to do it, you're going to know what to do. Okay. What are you trying to do? That's a your. Yeah, I made a mistake, okay? That's a your. Your drawn line cannot touch more than 1 point at a time. Okay? So I'll do a little demonstration over here while somebody is getting caught up. So if I have this graph and I've got a line drawn on it, is that a function?
No.
You don't think so? I think so. Because when I do this, okay, I'm only going to touch 1 point on that drawn line at any time I draw a line down the grid. It's a function. Vertical line test. You draw lines vertically down your, okay? If I had a graph like this and I had a point here and a point here, is that a function?
No.
Because when I do that, I touch both of them, don't I? So this is not a function. This is a function. Okay? Most of the time, not a function with a line drawn. You're going to have something where it's like maybe this. Okay? So that you're touching more than one part of the drawn line when you draw a vertical line. Okay? All right. Let's move on. Notes 2. Given the function g of x is equal to 4x minus 8, what is the value of g of 3? There you go. So g of 3, negative 3, sorry, is equal to 4x minus 8. So then you plug in 4 times negative 3 minus 8, and you get 12 minus 8, which is what? G of negative 3 will equal negative 20. Okay? Oh, negative 12, sorry. Okay? So your answer is B. How do you evaluate a function from the function notation? When given a value for x in the function notation, which is f of x, okay, then that number will be used to replace x in the expression or equation that is to be evaluated. So when given a value for x in the function notation, then that number will be used to replace the x in the expression or equation that is to be evaluated. What does it mean for a number or a set of numbers to be the element of a domain? Another topic we don't do very well on, domain and range. Only this isn't finding it on a graph yet. An element of a set such as the domain means the number is a member of the set or included in the set. For, sorry, not done, every member of the domain, which is your what value? Okay. The expression will need to be evaluated. In other words, if they give you more than one number and say this is the domain of the set of this expression or function, what is the range? Every time you put in a domain, you should be getting a range, correct? Sometimes that range may be repeated. Okay? Everybody got it? Okay. Third topic. The following formula, oh, you love these, is used to find the area of a trapezoid. What equation can be used to find B1? What?
Put on the screen. You don't see that Bill like
All right. So the first thing I'm going to do is I am going to write this. I'm going to write A equals 1/2 H B1 plus B2. Okay? The first thing I want to do, and there are different ways you can do this. I'm going to first distribute multiplication. Okay? There are different ways you could do this, but that's just me. So I'm going to do this, and I'm going to take 1/2 H times B1, and I'm going to get 1/2 H, sorry, that's an H. I don't want it to look like a B. H B1 plus, I'm going to take 1/2 H and multiply it by B2, 1/2 H B2, and I still have A equals. Okay? The whole thought here is I need to get B1 by itself. Okay? So I'm going to get rid of my fraction next because that settles a lot of things. Okay? So let's say second, I'm going to get rid of fraction. How can I get rid of that fraction? Multiply by 2. We've come so far. And I have to multiply everything by 2. So I'm going to take this, and I'm going to multiply it by 2, and I'm going to take this and multiply it by 2. What about this A? Do I have to multiply it by 2? No. Oh, yes, you do. What you do on one side of the equation, you must do on the other side. The reason I didn't have to multiply it by 1/2 H is because this was already here. I am adding 2 to this whole process, or multiplying by 2 to the whole process. All right? So now I end up with 2A on this side My pencil's running out. Oh, I'll get it working again. 2a is equal to, that wipes this out, correct? So all I'm left with is HB1. This wipes this out, so I have plus HB2, don't I? All right, third step I'm going to do. This is, and there are different ways to do these, okay? Not one way is the only way, all right? So now I am going to divide everything by what? 2? My whole goal is to get B1 all by itself on one side. By H. So, if I divide this by H, this by H, this by H, now that leaves me to A over H is equal to B, because these cancel, B1 plus B2. Now, how do I get rid of that B2? Subtract B2. So, last, subtract B2 from both sides. And I'm going to subtract B2 from this side. That wipes that out, and I end up with B1 all by itself. That's what I wanted, right? Now, be careful here.
What's the answer?
Okay. Be careful here. Because am I dividing B2 by H? No. So I've got 2a divided by H, subtract B2 is equal to B1.
B.
So it's B. Okay? If that, you know, you could always work from the answers back, but I think that's more complicated because you have to do it too many times. Okay? All right, how is solving literal equations similar to solving other equations? For both, you must use inverse operations. What does inverse mean? Opposite, correct. Inverse operations to isolate the required variable. And this is just like, you know, the thing you've got to get past is this is just like if you had a bunch of numbers. And so these are variables. You just deal with them the same way you would if you had, you know, x's and 5x plus 4y. It's just you're not used to seeing B1, B2, okay, and all that. All right? Why would you want to solve a literal equation for a variable? All right. This is a big, long, nasty answer. Okay?
I don't like it. Can you summarize it?
When working with scientific formulas, all right, you want me to summarize it? Easier to solve when needed I don't want to let's say this, needed, when needed, variable or answer, I guess, is isolated. If you tried to solve this up here and you had a problem and you were figuring everything, you were putting it all, if you just have the formula written so that you have an isolated variable and that's the answer you need. In other words, if I need to know about cars, I want C isolated because I don't want to have to sit here and once I figure out some things, try and then manipulate it, okay? Algebraic formulas easier to graph from slope intercept, sorry, I'm running out of room, intercept form where y is isolated. Topic number 4. No, just joking.
It's not a board. April Fools, you have to do this. April Fools, no homework.
What?
April Fools, no homework.
You're right. Take one.
I don't
Have
do
that
that
one.
homework. Hey.
So Jordan, I hear you were whining yesterday in writer time about your homework. Yeah. Oh, people speak. No, it wasn't Connor. It was nobody in algebra.
It was Mr. Small.
Mr. Small said that?
No, no.
It was Braden Walker.
No, you guys don't understand. Your peers will throw you under the bus every time.
We weren't whining about doing it.
You weren't whining about doing it? Oh.
I was. Yeah. I was.
I had two. Is there any we can mark out?
I want you to go to page 40, number 5.
No.
On page 40. The cost of making snow cones, there's 30 actually. The cost of making snow cones is $2 for material and 10 cents for ice for each snow cone. This represents what kind of, if you have $2 for material and 10 cents for ice for each snow cone, is that linear?
Yes.
Why is it linear? That's correct. See, these don't take very long. Number 6, which set does not describe a function? My gosh, how long is it going to take you to do that problem? Not a function. All right, do you see these aren't going to take very long? What? 7, which of the following is not a function? What one? Well, this is a function, isn't it? Right? Even if it's a parabola, are you going to touch more than one place on that parabola at a time?
No.
Okay. Well, this can be solved to y equals, right? So that's going to be a straight linear function, right? Well, it might be a diagonal, but it's a linear function. It's going to be a line, right? Okay. Well, you know that one's a linear function, right?
Yeah.
So rate of change, correct? Constant rate of change. So which one would it have to be?
Cup.
People. Common sense.
Yeah.
8. Which of the following is a function? This could be a y equals, right? Use common sense. Hey, I'm trying to help you out. This is an x squared. It's a parabola, right? Okay, what's this? Exponential. Aren't they a function? Because they just go like this and go like this, right? Okay, what about this? That's a linear line, isn't it? You've got to start recognizing these things, okay? And that's why this is important. So which one is a function? All of them. Oh, that took forever. Okay. What? Connor's papers on the floor?
No, that ain't mine. Not mine.
They're by page number?
I know, but
Page 40 should say, okay, look it, I did it wrong. Page 40 says 4, 5, 6, 7, 8. Oops, there's your 30. That's why you thought it was 29. The rest of them are fine. Okay, here you go. Just because I know I don't want to overwhelm you and make you think. Page 56, you can take 8, 9, and 10. No, you cross it off. 8, 9, and 10. 55, don't do that. I might have you come back and work it. Number 5. What? I heard somebody scribbling. Okay. I've already done 7 and 8 for you on page 40. You can take 5 and 6. So that leaves you how many now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Let's get rid of one more. Here, 12 on page 44. That'll make it an even, well, you know what? I'll even do this for you, and I'll even give you credit for those. There you go, 10, 11, and 12. Okay? All right? So, no whining, no complaining. Okay? No whining, no complaining. It is not, it's 18. How long did it take us to do some of those? Like a minute? Okay. That should be 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Sorry. Got to do something. But I did these. I did these already, so those are done, right? So I'm going to take your answers out of 20. Okay? Since I did 3, I'm just going to not count this one. I'm going to count those 2, and your score will be out of 20. Okay?
Whatever you want to do.
5 points apiece.
Wait a minute. If it's a horizontal line, that's not a function.
A horizontal line is a function. A vertical line is not a function. Horizontal line, what's wrong with a horizontal line?
Absolutely nothing.
If it goes like this, I'm never going to touch it. Now, you're looking at a vertical line, calling it a horizontal line. That's the problem.
Oh, you're the problem.
That's a vertical line, not a horizontal line. All right, that's it.